Solving systems of equations using elimination. So when is elimination a good choice to solve a system of equations? It's usually students' favorite, but don't always just use it. Why do we call it linear combination as well? That's what I think it was when I learned it. How do you decide what to multiply, one equations, both, or what? And where, same question as before, where do you go back to substitute, and do I really have to check? Those are the same answers as the last time. 6x plus 9y equals negative 18, and I've also got 6x minus 8y equals 50. So keep my original equations nice and safe. Same drill. Put the place for my answer there, ready to be filled in. Actually, let's make that a little bit smaller, so I can maybe get two problems on here. I don't know, we'll see. So I've got two equations. They both have a 6x in them. Well, the reason it's called elimination is we want to eliminate one of the variables. The way that we eliminated in substitution was we, figured out what one of them was equal to in terms of the other and plugged it in. We substituted. The way we're going to eliminate here is we're going to combine both of these lines, linear combination. Well, we're only going to do that and be able to get rid of one of the variables if we have one of the variables that has the same numerical coefficient but with the opposite sign. So since I have two equations with 6's in front of the x, I just need to pick either one and multiply by -1. So I'm going to take that second equation and I'm going to rewrite it as negative 6x plus 8y equals negative 50. Now, because it was just simple multiplication, it was just changing signs, I didn't take the time to put the number there to distribute. But every time I do this, I can make mistakes on signs. I verbally say this. If I can, I say it out loud. Please don't say it out loud during a test, but in my head at least I say, okay, I had positive, negative, positive. Now I have negative, positive, negative. And you'll hear me, muttering that around. So that was my second equation. Then I'm just going to bring down my first equation underneath it. So linear combination, we're going to combine these. We're going to add them. Some books teach, in this case, just subtract, but then you have subtracting negatives and people make mistakes. So I always just treat it as addition. I always want the same number with different signs, because then I can just do that. And then I know I can just add down and I don't have to worry about signs. So positive 8 plus 9, 17y, negative 50, negative 18, negative 68. Divide both sides by 17, and I get negative 4. So there's one of my answers. Put it up here so I don't forget I have another answer still. And then now, from this point forward, it's just like substitution. We're still going to substitute. So that's why I call the other one double substitution, because even if you do elimination, you still have to substitute. So it doesn't matter which of the equations I go back to. Just go back to one of the equations in the original box, right? Don't go to anything you've changed. 6x minus 36 equals negative 18. Add 36. Wishful thinking to think I might get two equations on here. So 6x equals 18. And x equals 3. Because we're not done, what do we always want to do? We always want to check it. So, do our check. Now I'm going to use the other equation. And so, the likelihood of me, making a mistake in both is pretty unlikely. Could happen, but I just have a much greater chance of catching the error if I use them both. So I've got 18 plus 32 equals 50. 50 equals 50, so I got the correct answer because those are the same. The answer is not 50, the answer is 3, negative 4. That's the ordered pair where there's two lines would intersect if we graphed them. So I'm going to do a whole nother video with more examples, but these are kind of the first two types in line. The first one we just had to change signs. This one we have to give a little more thought about what we want to multiply by. That was one of my opening questions. How do I know what to multiply by? And lots of times you have options. There's different things. So I could multiply by -3. That would get the x's to drop out, and that's perfectly fine. But I have another option. I can also multiply by 2. That will get the y's to drop out. That'll turn that 2y into a 4y, and then I'll have 4 and -4y. So 2 reasons I'm going to choose the 2. One, because last time I had the x's drop out, and I don't want you to think the x's always have to drop out. The other reason is I know my predisposition to make mistakes on signs. So if I cannot change the signs, that's the choice I'll take. So I'm going to multiply the top equation by 2, and it's going to become 2x plus 4y equals -16. Even though I didn't change the sign, I'm still going to check because I know that's a mistake I make. Original one was positive, positive, negative. This one's positive, positive, negative. Okay, feel pretty good. Now I'll bring down that second one. And again, elimination means something's better go away, or you didn't pick the right thing to multiply. You eliminated one of your variables, and now we've got 5x equals -40, x equals -8. So I've got one of my answers. I've got my x this time first, and now I can do just what I did in substitution. Substitute. I'm going to go back to one of my original equations. I'm going to go back to this one. I'm going to substitute -8 for x, so -8 plus 2y. Again, good habit to substitute into parentheses. In this case, it didn't matter, but this time I get 0. That's okay. 0 is a perfectly acceptable answer. Let's talk about the math for a second. 0 divided by 2 is 0. It's not undefined. 0 on the top is fine. You can divide 0 by other numbers. You just can't divide 0 into other numbers. So it looks like my solution is -8, 0. Looks like these two lines would intersect on the x-axis. If I really wanted to know, I could graph them and see if I'm right. But I can also just do a check. So again, I'm going to pick up my second equation this time. 3x minus 4y equals -24. -8 and 0. Answer I think I have. So -24 minus 0 equals -24. Yep, that looks good. So -8, 0 is my answer. Let's do one more example on the main video here, because really this is what will often happen. Often, your x and y terms don't have any common factors. Well, I shouldn't say common factors. 4 and 6 have common factors. But one doesn't go into the other, right? 4 doesn't go into 6, 2 doesn't go into 5. So I'm going to have to multiply both equations. And one of the reasons early on I was stressing fractions so much is to figure out what to multiply by. You're just basically figuring out, how could you get these to both be the least common multiple, either the x's or the y's. So meaning if I have 4 and 6, what's the smallest number those both go into? They both go into 24. So I could, if I wanted to, multiply this by 6 and this by 4, and just one of them be negative. That would be perfectly acceptable. Or I can look at 2 and -5. Now again, why am I going to choose the 2 and 5? Because they already have the opposite signs. So I don't have to multiply through by that negative. If I can avoid multiplying through by a negative, I'm going to do it. I'll even do it if it means bigger numbers, because I'm pretty good at numbers, but I can drop a negative pretty easily. So Now I'm going to look at 2 and 5. Those both go into 10. So I'm going to multiply this one by 2 and this one by 5. And let's use that color. So that one by 2 and that one by 5. So I'm going to multiply, again, multiplying all the things. That's the other reason I'm making a big deal about multiplying and dividing all the things. When you multiply all the terms, not just the ones you choose to. So 2 times 4x is 8x, 2 times negative 5 is negative 10y, and 2 times 13 is 26. Now I'm going to do my second equation and multiply by 5. So I've got 30x plus 10y equals 240. How did she do 240 so fast? Well, I know 10 times 48 would be 480, so half of it is half of that. All right, so again, I just want to double check my signs. On the top one was positive, negative, positive. That's true too. Positive, positive, positive on the second one. Okay, looks good. I can get rid of those guys. Over here I have 266. Over here I have 38x. And if I divide those, this one I didn't know. I did this up front. So x is 7. You guys believe me? X is 7. Let's see, how did I start thinking about that? Well, 40 goes into 240 6 times, and I'm just going to try from there. So, oh, I didn't make an answer like that. So it looks like x we're going to think is probably 7. And then we're going to substitute. I'm going to go to either of my original equations. Go to the top one. So 28 minus 5y equals 13 minus 28. So I get negative 5y equals negative 15, y equals positive 3. So I want to make sure that that's right. I'm going to do my check. Go to my other equation, 6 times something plus 2 times something is 48. We think it's 7 and 3. That gives me 6, that gives me 42. Yep, 42 plus 6 is 48. So there is solving by elimination. The biggest challenge for people is deciding what to multiply by. So when is elimination a good choice? Well, especially when all the terms are lined up. So some of those ones we did with substitution might just as well be done by elimination, but you have to know both methods. You can't just say, I'm just always going to do elimination. I don't like substitution. You have to be able to do both. Why is it called linear combination? Because you're trying to combine your like terms, and to do that and eliminate one of the things, right? Combining means adding. So we want to add them together and get something to drop out. Deciding what to multiply by, it's just kind of the same thing as finding the lowest common denominator of two fractions. What are the both things going to go into, and then multiplying what you have to turn the numbers into that number. If you can get away with doing one, great. If I have to multiply both and that means I don't have to change the sign, that's what I usually choose. And then always go back to your originals and always do your checks.